This is a question from computer organization. Which of the given number has its IEEE 754 32-bit floating point representation as this particular representation? The basic formula for the conversion of IEEE 754 32-bit floating point is as follows: minus 1 to the power s into 1.m into 2 to the power e minus 127. IEEE 754 32-bit floating point representation has XS128 notation, and the first MSB represents the sign bit for the mantissa, next 8-bit represents the exponent, and last the 23-bit represents the value of the mantissa. So the sign bit S here would be 0. This is S. The next 8 bits would be the exponent. This would be exponent. Next 23 bits would be the mantissa. This is how it is following. So S is equal to 0. M exponent, not M, exponent E is equal to next 8 bits 1 0 0 0 0 0 0 0. This is 128, and this is the mantissa. So we can write it as minus 1 to the power 0 into 1.1100. This can be extending till 23 bits into 2 raised to 128 minus 127. This becomes 1 into 1.11 etc. 2 to the power 1. So this is internally equal to 3.5. So the correct answer here is 3.5, option C. This is a question from digital logic design. The range of integers that can be represented by a n-bit 2's complement number system is, and 4 options are given. With n-bit, we can have distinct representation of 2 to the power n numbers. In case of unsigned numbers, it ranges from 0 to 2 to the power n minus 1. This is unsigned. Whereas in 1's complement representation, it ranges from minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. This is 1's complement. And in 2's complement notation, since there is only one single representation for 0, unlike 1's complement representation, we have minus of 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. So based on the options, option A is the correct answer here. And this is 2's complement notation. This is a question from digital logic design. How many 32x1 RAM chips are needed to provide a memory capacity of 256 kilobytes? So the RAM chip capacity is as follows. RAM chip capacity is equal to 32K cross 1, which is equal to 32 into 1024 into 1 bits. This is in bits. And the capacity required is equal to 256K, which is equal to 256 into 1024 into 8 bits. Now, number of RAM chips or chips is equal to memory capacity divided by RAM chip capacity. RAM chip capacity. This is equal to 256 into 1024 into 8 divided by 32 into 1024 into 1. So this and this gets cut short. 32 and 8, it becomes 1, and this becomes 4. 4 and 256, it goes 64. This will be 64. So we need 64 number of RAM chips, and the correct option is option C, 64. This is a question from digital logic design. A modulus 12 ring counter requires a minimum of, and 4 options are given. A ring counter requires n flip-flop for n states. A modulus 12 ring counter has 12 states starting from 0000 to 1011. So at least 12 bits are required. So a minimum of 12 flip-flop is required for a modulus 12 ring counter. So the correct option is option B, 12 flip-flops. This is a question from digital logic design. The complement of the Boolean expression AB into B bar C plus AC is, and four options are given. Let's try to find out the complement. We are given AB into B bar C plus AC. The complement would be A bar plus B bar plus B plus C bar into A bar plus C bar. We are complementing the literals as well as sum with and with sum. So this would be the final complement expression. And based on the options, option A is matching and it is the right answer here. This is a question from digital logic design. The code which uses 7-bit to represent a character is ASCII, BCD, EBCDIC or gray code. ASCII encodes 128 specific characters in 7-bit. BCD stands for binary coded decimal. It is a system of writing numerals that assigns 4-digit binary code to each digit 0 to 9 in decimal numeral. So this is a numeral system. And EBCDIC, extended binary coded decimal interchange code, is an 8-bit system. And this gray code is a binary numeral system where two successive values differ by only 1 bit. This is a numeral system. And the question asked is the code which uses 7 bits to represent a character. And the correct answer is option A, ASCII. This is a question from digital logic design. If half adders and full adders are implemented using gates, then for the addition of two 17-bit numbers using minimum gates, the number of half adders and full adders required are. So using a half adder, we perform two single bit binary number addition. Whereas using full adder, we perform three 1-bit binary addition, where it includes two sum bits and one carry bit. This is the basic information. So to add 70 numbers using minimum gates, the least significant bit of both the numbers can be added using one full adder, and rest of the 16 bits can be added using 16 full adders. So the correct option here is option C, one half adder and 16 full adder. This is a question from digital logic design. Minimum number of multiplexers required to realize the following function. F is equal to A bar B bar C plus A bar B bar C bar. Assume that inputs are available only in the true form and Boolean constant 1 and 0 are available. So let's write out the expression A bar B bar C plus A bar B bar C bar. You can rewrite it as A bar B bar into C plus C bar, which will be equal to A bar B bar. So let's try to see what is the minimum number of multiplexers required. Since the input is available only in its true form, we cannot directly derive A bar or B bar. We have 1 and 0 as constants. So using first multiplexer and A as the input 0 and this is input 1. So we pass 1 here and we pass 0 here. This is I0, this is I1. This would output A bar. This A bar would be the input of next multiplexer I0 and here the input will be 0. This would be input I1. Here we pass B. We would get A bar B bar as the output. So we require two 2x1 multiplexers to implement this function. So the correct answer is option B, 2. This is a question from digital logic design. The number of ones in the binary representation of 3 into 4096 plus 15 into 256 plus 5 into 16 plus 3 is what? So given expression is 3 into 4096 plus 15 into 256 plus 5 into 16 plus 3. This can be rewritten as follows. 3 can be written as 2 plus 1 into 4096. 15 can be written as 8 plus 4 plus 2 plus 1 into 256. 5 can be written as 4 plus 1 into 16 plus 3 can be written as 2 plus 1. Now writing in powers of 2, we can rewrite it as 2 plus 1, that is 3, into 2 to the power 12, that is 4096, plus 8 can be written as 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0 into 2 to the power 8 plus 2 to the power 2 plus 1 into 2 to the power 4 plus 2 plus 1. Here 1 can be written as 2 to the power 0, which is equal to, opening the brackets and multiplying, we'll get 2 to the power 13 plus 2 to the power 12 plus 2 to the power 11 plus 2 to the power 10 plus 2 to the power 9 plus 2 to the power 8 plus 2 to the power 6 plus 2 to the power 4 plus 2 plus 1. We know that 2 to the power 13 is 1 followed by 12 zeros. Also 2 to the power 12 is 1 followed by 11 zeros. This pattern follows on. So adding this number itself, adding the occurrence of these numbers, these are all in the powers of 2. We can count the number of zeros. This would give 1. Here it will be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So counting, we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total number of ones is equal to 10. So based on the options, option C is the right choice here. This is a question from digital logic design. The Boolean expression AB plus AB bar plus A bar C plus AC is independent of the Boolean variable and 4 options are given. Let's try to minimize the expression. AB plus AB bar plus A bar C plus AC. So we can minimize by combining the expressions like this. Taking A as common, B plus B bar. Taking C as common, we get A plus A bar. So we get A plus C. So the Boolean expression is independent of the Boolean variable B. The correct option here is option B, B. This is a question from data structures. If the sequence of operations push 1, push 2, pop, push 1, push 2, pop, 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 push 2, pop are performed on the stack, the sequence of popped out values are. Let's draw the stack. Initially we are pushing 1, then we are pushing 2. So right now this is the stack condition. Then we pop out 2. So 2 is popped. So 2 is here. Now we push 1 again into the stack. So the stack will be 1, 1. And now we push again 2 onto the stack. Now we perform 3 pop operations. 3 pop operations. 1, 2, 3. So we pop 2, 1, 1. 2, 1, 1. Now the stack is empty. So right now we are at this point. Now we push 2 onto the stack, then we pop it. So we write 2. So the sequence of pop operations are 2, 2, 1, 1, 2. And based on the options, option A is the right answer here. This is a question from algorithms. A machine needs a minimum of 100 seconds to sort 1000 names by quicksort. the minimum time needed to sort 100 names will be approximately what? Since this is quicksort and the minimum time complexity is asked, we'll consider the best case scenario, that is to sort n names by quicksort, it would take order of n log n time. Now based on this, let's try to calculate what will be the time required. Let T1 be time to sort 1000 names. This is equal to 100 seconds. Let's denote N1 as 1000 names. Similarly, T2 will be time to sort 100 names and N2 be 100 names. Now let's calculate the ratio T1 upon T2. It will be equal to N1 log N1 divided by N2 log N2. Substituting the values of T1, T2 and N1 and N2, we will get T1 is 100, T2 we are about to find out. 100 by T2 is equal to 1000 log 1000 divided by 100 log 100. We will get 1000 by T2 is equal to 10 into 3 by 2. Solving further, we will get T2 equal to 20 by 3, which is equal to 6.66. We are asked to find out what is the approximate time needed to sort 100 names. So going by the options, option B is the closest one to 6.66. So correct answer is option B, 6.7 seconds. This is a question from algorithms. A machine needs a minimum of 100 seconds to sort 100 names by quicksort. The minimum time needed to sort 100 names will be approximately what? This is a question from algorithms. 6 files F1 to F6 have 100, 200, 50, 80, 120, 150 records respectively. In what order should they be sorted or stored so as to optimize it? Assume that each file is accessed with the same frequency and 4 options are given. This is a classic example of optimal merge pattern. An optimal merge pattern will give the optimal result after performing sorted order operation. Every time it will take the least frequency elements and perform the merging. So based on this fact, let's try to find the solution to this. So we are already given F1 is equal to 100, F2 is equal to 200, F3 50, F4 80, F5 120 and F6 150. So let's take the lowest 2 frequency and merge it. Merging this, we will get 130. So let's write it down, 50 and 80. This is F3, this is F4. Merging this, we will get 130. Now the next two smallest number of records are 100 and 120. Let's merge those two, 100 and 120. This is F1 and this is F5. So merging this, we will get 220. Now we have 130, 220. Then we have 200. Next we have 120 again. Then we have 200. This 120 is already taken out. Next we have F6, that is 150 and 200. This 150 is F6. This 200 is from F2. Now among these, the least value that is there is 150. Let's merge it with this 130. Merging this with 130, we'll get 150 here. This is F6. This will result in 280. Now we have 200, 220 and 280. Merging 200 and 220, we will get 200 will be here. This is F2. We will get 420. Now merging these two, finally we will get the result as 700. Now the order in which the files are merged will give us the correct answer. So the correct answer would be first F3, then F4, then we merged F1. So let me write the ordering: 1, 2, 3, 4. This would be 5. This would be 6. This would be the ordering. That is F3, F4, F1, F5, F6 and F2. So based on the options, option A is the right answer here. This is a question from data structures. A hash table with 10 buckets with one slot per bucket is shown in the figure. The symbols S1 to S7 initially entered using a hash function with linear probing. The maximum number of comparisons needed in searching an element that is not present is. And 4 options are given. So this is linear probing, and maximum number of comparisons for an item not present is equal to maximum cluster size plus 1. So let's find the maximum cluster size. This is a cluster, its size is 2. This is a single cluster of this is a cluster of size 1. This is 1, and this is altogether this and this together form another cluster of size 4. So the maximum number of comparisons that is needed in searching an element that is not present would be, if we start searching from S6, then we'll go to S3, then we'll go for S7 and S1, then only we'll find an element if not present or not. So the result is 4 plus 1, which is equal to 5. So 5 is the right answer here. This is a question from data structures. The Q data structure is to be realized using a stack. The number of stacks needed would be, and 4 options are given. This is a very basic question in data structure regarding stack. So a Q data structure can be realized using a stack, and the number of stacks needed would be 2. Either it can be making the pop operation costly, or it can be done by making the push operation costly. So anyhow, the correct answer is option B, 2 stack. This is a question from databases. Consider the following relationship entity diagram. Which of the following possible relations will not hold if the above ERD is mapped into a relational model? If we convert the given ER diagram into a relational model, then we can create a table for each entity. So when we create a table for the entity person and exam, we get 2 tables. So the table structure is as follows. We have entity, then table name, followed by the primary key. So for the entity person, the primary key would be NID, and the table name will be person with the following attributes: name, comma, NID. Here NID is the primary key. Now the next one we will get is exam. For exam, the table name will be exam, and exam ID will be the primary key, and exam name will be another attribute. So primary key will be exam ID. Now for the relationship, the entity qualification, this we cannot add qualified date in any of the two tables formed. So we need to create a new table using the primary key for both entity person and entity exam. So the third table, I'm writing it here, it will be qualification, and the table name will contain qualification with NID, exam ID. I'm writing exam ID as EXID and qualified date. So these three tables are formed. Now let's see the options. Option A, person, NID and name. Person, NID and name. This is not the right choice because we are able to make a table. Second one is qualification, NID, exam ID, qualified date. Yes, this is there. This is also not the right choice. Fourth one, exam. It has exam ID and exam name. Yes, this is there in this table. And option C, exam ID, NID, exam name. It doesn't seem a feasible option. So based on the options, option C is the right choice here. This is a question from databases. Consider the following log sequence of two transactions on a bank statement with initial balance 12,000. That transfer 2,000 to a mortgage payment and then apply 5% interest. And this is the log of two transactions. Suppose the database system crashes just before record 7 is written. When the system is restarted, which one statement is true of the recovery procedure? So the steps that is to be taken after a database is crashed includes step 1 is undo the uncommitted transaction. Undo uncommitted transaction. Even undo the uncommitted records which are before the checkpoint. Undo happens in the reverse order, that is from bottom to top. This is an important point. The second step is redo committed transaction. We need not redo the records which are already committed before the last checkpoint. Redo happens in the original order, that is from the top to bottom. With these simple steps, any database recovery question can be easily solved. So based on this, let's try to solve it. So this transaction is already committed, and before this commit of T2, this happened. So based on the 2 points given, since T1 is already committed, we have to redo the steps 2 and 3. This has to be redo and this step has to be undo. So let's see the options. We must undo log record 6 to set B to 10,000. Yes, this is correct. And then redo log records 2 and 3. Yes, this is also correct. So based on the options, option B would be the right answer here. This is a question from database. Given a block can hold either 3 records or 10 key pointers. A database contains n records. Then how many blocks do we need to hold the data file as well as the dense index? So number of blocks needed to store data file with n records. This is equal to n by 3. And number of blocks needed to store dense file or dense index file is equal to n by 10. Total blocks is equal to n by 10 plus n by 3. So we get 3n plus 10n divided by 30, which is equal to 13n by 30. So option A is the right answer here. This is a question from web technology. The correct syntax to write, "Hi there, in JavaScript is, and 4 options are given. So the syntax to print a statement in JavaScript is as follows. It is document dot write dot the text we need to print or write. So based on the options here, we are asked to print hi there. So let's substitute this text with hi there. So based on the options, option B would be the right answer. That is document dot write hi there. So option B is the right answer here. This is a question from databases. Let R equal to A, B, C, D, E, F be a relational schema with the following dependencies. We have C derives F, E derives A, EC derives D, A derives B. Which one of the following is the key of R? So let's see how can we derive. Let's see the first option, CD. Using CD closure, what all we can derive? C can derive C, and using C we can derive F. With F we cannot derive anything. With D also we cannot derive anything. So CD is not the right option. Let's see EC closure. EC. Using EC we can derive E and C first, and using C we can derive F. Now using E we can derive A. Using A we can derive B. Now using EC together we can derive D. So we have A, B, C, D, E and F. So the whole relation R can be derived using EC closure. So EC is the key of R. Option B is the right answer here. This is a question from C programming. We are given a code fragment. Here the function foo is accepting integers x and y, and this is performed. In the main function we have int x equal to 5.5 and foo of x comma x is called. What is the final value of x in both called by value and called by reference? So the first point here is that when a floating point constant is assigned to an integer value, it gets truncated and only the integer part gets stored. So x will be having the value of 5. Now when we perform call by value, whatever happens inside the function, it is local to this function only, and whatever happens here in the main function is local to the main function. So no modification that is being done by the function foo is reflected in the main function. So this would return x value as 5 itself. So in call by value, we get 5 as the answer. In call by reference, the reference to the original memory location is passed. So suppose initially x and the memory address is 100, the value is 5. To these integer pointer variables x and y, we are passing this reference. So x will be having value 100, y will be also having the value 100. This is a reference to this value. Now what happens here is x equal to x plus 5, x equal to x plus y, x equal to x plus y. So 5 plus 5, it becomes 10. So it becomes 10 here. Now in the second statement, y equal to y plus x, both are referring to this x only. So this will be having 10 plus 10, which is equal to 20. So this would return 20 in call by reference. So based on the options, option C, 5 and 20 is the right answer here. This is a question from database. We are given a relational schema with the relation supplier, parts and catalog. And we are asked the following SQL query, that is select s.name from suppliers S where s.sid not in, select c.sid from catalog C where c.pid not in, select p.pid from parts P where p.color not equal to blue. Assume that the relations corresponding to the above schema are not empty. Which one of the following is the correct interpretation for the above query? So let's try to solve this question. Now consider the following table. This is the parts table. Parts. We have 3 rows, 3 columns. So let's write the values in it. This is a basic assumption. We have name, ID, and color. Let the names be A, B, C, D, E, F, G, H, and the ID be 1, 2, 3, 4, 5, 6, 7, 8. Now let's write the colors. Colors include blue, 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 red, 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 and one color let it be null. That is, it is not having a color. Now, based on the query, that is, select p.pid from parts P where p.color not equal to blue. So we are selecting all those rows where color is not equal to blue. Now, the result of the query, select p.pid from parts P where p.color not equal to blue would give this table. That is, it will select all those rows whose value is not blue. That is E, F, G and H. We have E, F, G, H. Values would be 5, 6, 7, 8 and the colors are red, red, red and no color is mentioned for this. Now the query, select C.SID from catalog C where C.PID not in this particular result. So we are selecting those SIDs from catalog C where C.PID not in this result. So this would result in selecting all those SIDs which are not part of this result. So this would return this table. That is, this would result this. So we will be having A, B, C, D and the ID will be 1, 2, 3, 4 and the color will be blue, 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 blue. Let's write. Now the final query, select S.name from suppliers S where S.SID not in this table, the result of this. So this should give this result itself, that is this table. So finally the answer would be this table. Final answer. Now let's see the options. First option is it returns the name of all suppliers who have supplied a non-blue part. This is false. Now the non-blue parts does not include the null values. So this is false. Second option is also false because it will include both null values and the blue parts. Third option is also false because it will only include only blue parts. But fourth option is true because it will include non-blue parts as well as null values. So this is the right answer. So let's see the option. That is option D is the right choice because it finds the name of all suppliers who have not supplied only non-blue parts. So option D is the right choice. This is a question from databases. Consider the following schema, EMP, where EMP code, name, sex, salary, and department are the attributes. The simple SQL query is executed. Select department from employee, where sex equal to M, group by department, having average of salary greater than select average salary from EMP. What will be the output? So this particular statement takes the average salary of all the employees, and in this particular statement it selects all males from the department whose salary is greater and it is grouping by the department. So here we are going to get the name of all departments in which the average salary of male employees is greater than the average salary of all employees in the company. So the output will be based on the options. Option D, average salary of male employee is more than the average salary of the organization. So option D is the right answer here. This is a question from compiler design. Given the following expression, E derives E star F or F plus E or F derives F minus F or ID. Which of the following is true? This is asked regarding the precedence. So the basic thumb rule is that the operator at lower level has higher precedence. So here minus is at the lower level because we cannot derive F directly. So minus is at the lower level, then star or plus are at the same level because they are can be derived by this expression E. So the order will be minus and star will be equal to plus. This is operator, this is operator, this is operator. This will be the order of precedence. Now let's see the option. Star has higher precedence than plus. No, this is wrong. Minus has higher precedence than star. True. Plus and minus have same precedence. False. Plus has higher precedence than star. This is also false. So based on the options, option B is the right answer here. This is a question from compiler design. The number of tokens in the following C statement is, and the statement is given. So let's rewrite this statement once again. Print f I equal to percentage D, comma, ampersand I equal to percentage X, I ampersand I. This is the statement. So let's count the number of tokens. This would be one token. This would be second token. Whatever that is inside the quotes till here will be considered as a single token. This is 3. This would be 4. This would be 5. This would be 6. This would be 7. This would be 8. And this would be 9. So the number of tokens in this D in the following C statement is option D, 9. This is a question from compiler design. Which grammar rule violates the requirements of the operator grammar? A, B, C are variables and small letter A, B, C are terminals. And 4 grammar rules are given. So let's understand the basic rules regarding operator grammar. The first rule is in operator grammar, production rules which have adjacent non-terminals on the right hand side are not allowed. Productions that have two adjacent non-terminal on RHS is not allowed. The second rule is empty production rules are also not allowed. Empty production rules are not allowed. So based on these two rules, let's see the productions. A derives BC. This is violation of rule number 1. So this is not a operator grammar. A derives C, C, B, B. There is no issue with this production rule. A derives B, A, C. Here also no issue with the production rule. A derives epsilon. Empty production rules are not allowed. So these two, 1 and 4 violates operator grammar rule. So based on the options, option D, 1 and 4 only is the right answer here. This is a question from compiler design. Which one of the following is a top-down parser? Recursive descent parser, shift left associative parser, SLR of K parser, LR of K parser. So the parsers can be either top-down or bottom-up. In top-down parsers, some of the example includes recursive descent parsing and LL of 1 parsers. These are examples of top-down. And in bottom-up, we have SLR of K, LR of K parsers in bottom-up. So the question asked here is, which is an example of top-down parser? So option A, recursive descent parser is an example of top-down parser. It is the right answer. This is a question from compiler design. YARC stands for, and four options are given. YARC is a standard parser generator for Unix operating system. It is used as a parser in C programming language, and it stands for yet another compiler. So based on the options, option D is the right answer. YARC stands for yet another compiler. This is a question from compiler design. Which of the statement is true? Option A. LALR parser is more powerful and costly compared to the others. This is false because canonical parser CLR is the most powerful parser when compared to other LR parsers. The order of powerfulness can be CLR is greater than LALR greater than SLR greater than LR of 0. So CLR is the most powerful parser. This is wrong. Option B. All CFGs are linear precedents and not all grammars are uniquely identified. This is also wrong. All linear precedent grammars are context-free languages and not vice versa. So this is also not correct. Option C. Every SLR grammar is unambiguous, but not every unambiguous grammar is SLR. This is true. SLR grammar cannot be ambiguous, but if any unambiguous grammar has shift reduce conflict, then it cannot be parsed with the help of SLR parser. So this option is true. Option D. LR of K is the most general backtracking shift reduce parsing method. LR of K has a K look ahead which can always see ahead of the input in order to avoid backtracking. So it is a non-backtracking parser. So this is also wrong. So based on the options, option C is the right answer here. This is a question from operating system. Semaphores are used to solve the problem of race condition, process synchronization, mutual exclusion, none of the above. And four options are given. So let's find out the answer. So what is a semaphore? A semaphore is a variable that has an integer value upon which two operations are defined, that is wait and signal. This is solved. This is used to solve the problem of critical section. Now let's see the options. Race condition. A race condition is a section of code where if multiple threads or processes execute, its final outcome is undefined and it depends upon the order in which they execute. So some sort of ordering or mutual exclusion is required to avoid this condition. Second one is mutual exclusion. A mutual exclusion is a program object that prevents simultaneous access to a shared resource. So here also semaphores are required. Third one is process synchronization. It is a means of sharing system resource by which processes in such a way that concurrent access to a shared data is handled, thereby minimizing the chance of inconsistent data. So based on the options, all these three uses semaphore to solve. So race condition, process synchronization and mutual exclusion would be the correct answer. So option C, all of the above is the right answer here. But there can be some confusion because if we select all of the above, then this option none of the above can also come. So while answering such question, we have to think carefully and write the answer. So in this case, all of the above is the right answer. This is a question from operating system. If there are 32 segments, each having size 1 kilobyte, then the logical address should have how many bits? So the logical address would be for each segment has 1 kilobytes and there are 32 segments. So 32 into 1024. This would be the total logical addresses that is available, and how many bits that it requires is we can rewrite it as 2 to the power 5 into 2 to the power 10. So it requires 15 bits, that is sum of this plus this. 15 bits are required for the logical address. Based on the options, option C is the right answer here. This is a question from operating system. In a lottery scheduler with 40 tickets, how we will distribute the tickets among 4 processes such that each process gets 10, 5, 60 and 25% respectively. And the options are given as follows. So we have 40 tickets and the processes are P1, P2, P3 and P4. So this gets 10%, this gets 5%, P3 gets 60% and P4 gets 25%. So 10% means 0.1 into 40, which is equal to 4. This would be 0.05 into 40, which will be equal to 2. This would be 0.6 into 40, which will be equal to 24. This would be 0.25 into 40, which will be equal to 10. So based on the options we have option C 4, 2, 24 and 10. So option C is the right answer here. This is a question from operating system. Suppose a system contains n processes and system uses the round robin algorithm for CPU scheduling. Then which data structure is best suited for ready queue of the process? So circular queue is the best data structure for round robin CPU scheduling algorithm. So option C, circular queue would be the right answer here. In round robin scheduling, if the timer goes off first, then the process is swapped out of the CPU and moved back at the back end of the ready queue. So the ready queue is maintained as a circular queue. So when all processes have had a turn, then the schedule gives the first process another turn and so on. So a circular queue would be best suited for a round robin scheduler. This is a question from operating system. A hard disk has the following parameters. Number of tracks equal to 500, sectors per track equal to 100, bytes per sector equal to 500, and time to move the head from one track to the next track is 1 millisecond. Rotational speed is 600 rpm. What is the average time taken for transferring 250 bytes from the disk? So the formula for average time taken to transfer is equal to sum of average seek time plus average rotational delay plus data transfer time. It is a parameter of or the sum of all these three parameters. Now average seek time. It is given that to move from one track to the next one it takes 1 millisecond. So from track 1 to, let's write it once again, from time taken to move from track 1 to track 1 is equal to 0 milliseconds. From track 1 to track 2 is equal to 1 millisecond. From 1 to track 3 is equal to 2 milliseconds. So how many tracks we have? 500. So from track 1 to track 500 is equal to 499 milliseconds. So average seek time is equal to sum of the whole divided by 500, as 500 is the number of tracks. Summation of 1 plus 2 plus 3 plus etc. 499 divided by 500. This is equal to 249.5 milliseconds. So this is one value, that is the average seek time. Now it is given that 600 is the RPM value, that is 600 rotation in 60 seconds. So for one rotation, how many seconds are needed? So for one rotation, it requires 60 by 600 seconds, which is equal to 0.1 second. So average rotational delay is equal to half of one rotation, which is equal to 0.1 divided by 2, that is equal to 0.05 seconds. This is equal to 50 milliseconds. This is the second parameter. Now we are given that one rotation can read one whole track. So the amount of data that can be read in one complete rotation is 100 into 500, which is equal to 50,000 bytes in one rotation. And one rotation takes 0.1 seconds. So 0.1 seconds we can read 50,000 bytes. So to read 250 bytes, how many seconds we need? That is x seconds we require time for 250 bytes. This is equal to 0.1 into 250 divided by 50,000. This is equal to 0.5 millisecond. So these are the three parameters. So average time to transfer is the sum of average seek time, that is 249.5 milliseconds, plus average rotational delay, that is equal to 50 milliseconds, plus time to transfer the data, that is 0.5 milliseconds. This is equal to 300 milliseconds. So let's see the options. Based on options, option D, 300 milliseconds is the right choice. This is a question from operating system. At a particular time of computation, the value of counting semaphore is 7. Then 20 P operations and 15 V operations were completed on this semaphore. The resulting value of the semaphore is, and 4 options are given. So in counting semaphore, there are two operations. One is P and another is V. P decrements the value of semaphore by 1, whereas V, it increments the value of semaphore by 1. So initially the value of counting semaphore is 7. Now 20p operations are performed. So after 20p operation we have 7 minus 20, which is equal to 13, minus 13. Now then we perform 15v operation. So after 15v operation we get minus 13 plus 15, which is equal to 2. This is the final value of the semaphore. So option B, 2, is the right answer here. This is a question from operating system. Increasing the RAM of a computer typically improves performance because virtual memory increases. This option is false because virtual memory of a computer is not depending upon the RAM. So this is not correct. Second one is larger RAMs are faster. This is also false. Actually, the type of RAM determines its fastness and not the size of the RAM, because SRAM is much faster than DRAM. So the type of RAM is determining its fastness. So this is also not correct. Few page fault occur. This is true because more pages can be brought into the main memory by increasing the RAM. So option C can be a correct option. Option D, fewer segmentation fault occurs. Segmentation fault is a common condition that causes a program to crash. This is because the program is trying to read or write an illegal memory location. It is clear that segmentation fault is not related to the size of the RAM, or it is not related to increasing the RAM. So option D is also not the right choice. So based on the options, fewer page fault occurs, and option C is the right answer here. This is a question from operating system. Consider the following program: main and 3 fork statements are called in a series. How many new processes will be created? So the number of processes created with n fork call in series is equal to 2 to the power n, and number of new processes created would be 2 to the power n minus 1. The question asked here is new processes. So the fork system call is called in series. So n will be equal to 3 here. So 2 to the power n minus 1 will be 2 to the power 3 minus 1, which will be equal to 7. So 7 new processes will be created. Option C is the right answer here. This is a question from C programming. Consider the following C declaration: a structure having short S of 5 NRA and a union of float and long. Assume that the objects of the type short, float and long occupies 2, 4 and 8 bytes respectively. So short has 2 bytes, float has 4 bytes and long has 8 bytes. The memory requirement for variable t, ignoring alignment consideration, is, and 4 options are given. So the basic concept to understand here is that the total size would be the sum of all the data members inside a structure. That is one point. The other point is that what is union? Union is a user defined data type that is used to store different data type in same memory location. Union store different data type in same location. The total size of union is the size of the largest data member. Size of union is equal to size of largest data member. This is an important point. Now let's see how to solve. So the members of the structure would include short, which is having 2 bytes. Since it's an array, so we have 2 into 5, which is equal to 10 bytes. This is 1, plus size of this whole union will be equal to the size of the largest data member in it. Long has 8 bytes and float has 4 bytes. So size of long would be considered here. It is equal to 8. So the total size would be 10 plus 8 equal to 18 bytes. So based on the options, option B, 18 bytes is the right answer here. This is a question from database. If a node has k children in a B tree, then the node contains exactly how many number of keys? And 4 options are given. In a B tree, if node contains n keys, then it has n plus 1 child pointers. So if we have k children, then k children means k child pointers. Conversely, based on this fact, we can say that it should have k minus 1 keys. So option B, k minus 1 is the right answer here. This is a question from algorithms. The time complexity of the following C function. They are given a function integer recursive which accepts an integer variable n. If n equal to 1, it returns 1. Else it returns recursive of n minus 1 plus recursive of n minus 1. So let's find out the time complexity. We can write t of n is equal to 2 into t of n minus 1 plus a is the recurrence equation for the following pseudocode. A is the constant order of one time cost for the non-recursive function it takes. So solving it by back substitution, we can write it as t of n minus 1 is equal to 2 into t of n minus 2 plus a. Substituting back, before that let's write t of n minus 2, which is equal to 2t of n minus 3 plus a. Following this, we will get t of n is equal to 2 into 2t of n minus 2 plus a, which is equal to 4 into t of n minus 2 plus 3a. Now again substituting the value of n minus 2, t of n will be equal to 8 t of n minus 3 plus this 3a can be written as 2a plus a. So ultimately we'll get 4a plus 2a plus a. Solving this continuously till kth iteration, where t of 1 we will obtain. We can rewrite it as 2 to the power k t of n minus k plus 2 to the power of k minus 1 into a. Now, on substituting for the base condition t of 1, which is equal to 1, we can write t of, again rewriting it like this, 2 to the power k t of n minus k plus 2 to the power k minus 1 into a. This is the equation. Now t of 1 equal to 1, so we'll get n minus k equal to 1, which implies k is equal to n. So our solution becomes 2 to the power n into t of 1 plus 2 to the power n minus 1 into a, which will be equal to 2 to the power n plus 2 to the power n minus 1 into a, which is equal to order of 2 to the power n. So the time complexity would be option D, order of 2 to the power n. This is a question from graph theory. The number of spanning tree for a complete graph with 7 vertices are, and 4 options are given. So the basic formula is number of spanning tree for complete graph with n vertices is equal to n to the power n minus 2. Here n is equal to 7. So we have 7 to the power 7 minus 2, which is equal to 7 to the power 5. Based on the options, option B is the right answer. This is a question from algorithms. If one uses straight two-way merge sort algorithm to sort the following elements in ascending order, and the elements are given as follows, then the order of the elements after second pass of the algorithm is. So in the initial pass, what happens is as follows. Let's write the array first. 20, 47, 15, 8, 9, 4, 40, 30, 12, and 17. After round 1, what happens is we iteratively sort it, and the array will be divided into n by 2 sorted order list. So since it's two-way merge sort, we first sort these two elements, then we'll sort these two elements, then these two, and finally these two. This is what happens. This sorted list would be 20, 47 as it is. Next list would be 8, 15. Next list would be 4, 9. This would be 30, 40. This would be 12, 17. This is round 1. Now in round 2, iterative we solve these two. We'll sort these two, and this, since it's not having any pair, it will sort it alone. When combining and sorting this, what happens is we'll get 8, 15, 20, 47. This is one sorted list. This sorted list would be 4, 9, 30, 40. This would be second sorted list. This would be 12 and 17. This is round 2. Now based on the options, option B is matching. We have 8, 15, 20, 47. This is same. Then we have 4, 9, 30 and 40. 4, 9, 30 and 40. Then we have 12 and 17, 12 and 17. So option B is the right answer here. This is a question from theory of computation. Let R1 and R2 be regular sets defined over the alphabet. Then R1 intersection R2 is not regular. R1 union R2 is not regular. Sigma star minus R1 is regular. R1 star is not regular. So regular languages are defined under, or regular languages are closed under. Regular languages are closed under union, complement, intersection, as well as clean closure. So based on this property, let's find out the answer. R1 intersection R2 is not regular. No, this is wrong because regular languages are closed under intersection. This is wrong. R1 union R2 is not regular. This is also wrong because regular languages are closed under union. R1 star is not regular. This is also wrong because regular languages are closed under clean closure. Now, sigma star minus R1 is essentially R1 complement. So regular languages are closed under complement. So sigma star minus R1 is regular is the right answer here. So option C is the correct answer. This is a question from computer networks. The DNS maps the IP address to option a binary address of string, an alphanumeric address, a hierarchy of domain names, a hexadecimal address. So DNS, it stands for domain name system. That is the first point. DNS, it stands for domain name system. It maps the domain name into Internet Protocol address. Hence, DNS maps the IP address to a hierarchy of domain names. So based on the options, option C is the right answer here. This is a question from web technology. To add a background color for all H1 elements, which of the following HTML syntax is used? So the basic syntax to add background color for a particular tag is tag name followed by background hyphen color hyphen the color code. So here we are adding the color code FF FF FF. So the question is asked to add a background color for all H1 elements. So the correct answer here would be the tag would be H1. Then it will be following this syntax. This will be substituted here. So based on the options, option A is the right answer here. So one another important point is that H1 tag, it defines most important heading, and H6 tag, H6 defines least important heading. So option A here is the right answer. This is a question from web technology. To declare the version of XML, the correct syntax is, and four options are given. The correct syntax to declare the version of XML is this: XML space version is equal to 1.0 slash. This is called XML prologue. We can even add the encoding that is to be specified. If we add this, then it would be XML version is equal to 1.0 followed by encoding is equal to UTF-8. This is just a sample encoding method. So this X is called XML prologue and it is an optional part. If it is existing, then it should come first in the XML document. So the XML can come in variety of formats. So it is better to specify the encoding technique. So based on the options here, option C would be the right choice. This is a question from computer networks. A T-switch is used to, and four options are given. A T-switch is actually a passive device. That is the first point. It's a passive device in which information can be sent in both input and output direction. Information can be sent in both input and output direction. Either side of the T-switch can be input or output. Also, a T-switch is used to rearrange the connection between computing element. So that is the important point here. So option D based on the options will be the correct answer here. That is to rearrange the connections between the computing equipments. This is a question from satellite communication. What frequency range is used for microwave communications, satellite and radar? Microwave is a form of magnetic radiation with wavelength that is ranging from 1 meter to 1 millimeter, and the corresponding frequency is ranging from 300 megahertz to 300 gigahertz. So, a extremely high frequency of 30,000 kilohertz or more is used for microwave communication, satellites and radar. So, based on the options, option D is the right choice. This is a question from computer networks. How many bits internet address is assigned to each host on a TCP/IP internet, which is used in all communication with the host? So, IP stands for Internet Protocol. It is a unique address that identifies each device connected to the internet, and it uses Internet Protocol for communication. In IPv4, 32-bit IP address is assigned to each host connected to the internet for communication. So 32-bit is used. Hence, an internet address of 32-bit is assigned to each host on a TCP/IP internet, which is used in all communication with the host. So based on the options, option B is the correct answer. This is a question from computer networks. How many characters per second, 7 bits plus 1 parity, can be transmitted over a 2400 bits per second line if the transfer is synchronous? One start and one stop bit. So size of each character is equal to 7 plus 1, which is equal to 8 bits. And the bandwidth is 2400 bits per second. So number of characters per second is equal to 2400 bits per second divided by 8 bits. So we get 300 bits per 300 characters per second. So we have 300 characters per second. So the correct answer is option A. One important point to note here is that in synchronous mode of transfer, we do not require any start and stop bit. But in asynchronous mode of transfer, these bits are added to the number of bits in each character. This is an important note. So in synchronous, no start and no stop bit is needed. This is a question from computer networks. In CRC, if the data unit is 1001, 11001 and the divisor is 1011, then what is the dividend at the receiver? And 4 options are given. So the first thing we have to do is append n-1 number of zeros to the dividend. Here the n will be the number of bits in the divisor minus 1. So let's do the first step. The dividend is 100111001 and the divisor is 1011. It has 4 bits. So n is equal to 4. N minus 1 bits are appended as zeros. So 3 bits 000 and we perform XOR operation 1011. 1, it will be 1011. This will be eliminated. We'll write 0 1 0. This one will be brought down. This is 0. So we'll get 0 0 0 0. Take this out. It is 1 0 1 and this is brought down. So 1. It will be 1 and the value is 1 0 1 1. We remove this. It will be 0 0 0 0. This will be 0 0 0 0 0. This is removed 0 0 0. Next we bring down the next 0. This also will be 0 0 0 0. We'll remove this. We'll bring 0 0 0 and this 1. When we bring this one, it will be 1 here. It will be 0 0 0 0. Remove this. It will be 0 0 1 and it will be brought down here 0. It will be again 0 0 0 0. Remove it. It will be 0 1 0 and the second last one, like second last 0 we bring here. It will be 0 0 0 0. Removing this we'll get 1 0 0, and we bring down the last 0. We perform the XOR operation. We get 1 0 1 1. Perform XOR operation, we get 0 1 1. So this gets appended with the dividend, that is 1 0 0 1 1 1 0 0 1 0 1 1. So based on the options, option B is the right choice. This is a question from computer networks. An ACK number of 1000 in TCP always means that 999 bytes have been successfully received, 1000 bytes has been successfully received, 1001 bytes has been successfully received, and none of the above. So the acknowledgement number is the sequence number of next byte the receiver is expecting. The sequence number is the byte number of the first byte of the data in the TCP segment sent. So these are the two important points. So an acknowledgement number in TCP tells which byte it is expecting to receive next. So there can be two scenarios here. Since the initial sequence number is not mentioned, if initial sequence number is equal to 1, then ACK of 999 means, sorry, ACK of 1000. ACK of 1000 means that 999 bytes has been delivered. If the initial sequence number is equal to 0, then it means that the acknowledgement of number of 1000, it means that 1000 bytes has been delivered. Since there are two situations based on the value of initial sequence number, we cannot outrightly say either A or B will be correct. So the correct answer here would be D, none of the above. This is a question from computer networks. In a class B subnet, we know the IP address of one host and the mask is given as, and these are the values. What is the first address? That is the network address, and 4 options are given. So two important points to note here is that the first point is we can obtain the network address by performing bitwise operation of the IP address and the subnet mask. That is the first point. Now, since we are performing bitwise AND operation, we need not perform bitwise AND operation for this octet and this octet, because since it's all ones, we will directly get these two values. Also, one another important point is that the last octet, since this is 0, we need not perform bitwise AND operation because this would return 0. So ideally the IP address would be as follows. It will be in this manner: 125. Since we are performing bitwise mask with this first octet of 255, it will be 125.134. This would be the missing value which we have to find, dot 0. This would be the IP address of the first IP address. So this part, the third octet, is the one which we have to find out. So right now itself we can eliminate option C. Now let's write the binary form of the 112, that is the third octet of the IP, and the binary form of 224, that is the mask, and perform the bitwise AND operation. So 112 is written as 0 1 1 1 0 0 0 0, and 224 is written as 1 1 1 0 0 0 0 0. So this would be the first four, 1 2 3 4. This would be the next one. Now performing bitwise AND operation, we get 0 0 0 0. This one, this one, this one, and this one. This one would be 0. This would be 1. This would be 1, and this would be 0. So the answer that we'll get is, this is 96, because 8 4 21, 16, 32, 64, 128. This will be the values. So 64 plus 32 would give 96. So based on the options we have 125.134.96.0 as the network address. And based on the options, option A is the right answer here. This is a question from computer networks. A certain population of Aloha users managed to generate 70 requests per second. If the time is slotted in units of 50 milliseconds, then the channel load would be what? So number of requests per second is equal to 70. Time slot is equal to 50 into 10 to the power of minus 3 seconds. Number of slots in 1 second is equal to 1 by 50 into 10 to the power of minus 3, which is equal to 20. So channel load is equal to number of requests in 1 second divided by number of slot in 1 second. Number of requests in 1 second divided by number of slot in 1 second, which is equal to 70 divided by 20, which is equal to 3.5. So the right answer here is option B, 3.5. This is a question from computer networks. We are asked to find out the statements which are false, and it is related to ping. So let's understand the basic concept behind what a ping is. A ping is a TCP IP application that sends datagram once every second in the hope of an echo response from the machine being pinged. If the machine is connected and running a TCP IP protocol stack, it should respond to the ping datagram with a datagram of its own. If ping encounters an error condition, an ICMP error message is returned. Also, ping displays the time of the return response in milliseconds or one of the several error messages. So this is the basic concept about ping. Now let's see the options. Ping is a TCP IP application that sends datagrams once every second in the hope of an echo response from the machine being pinged. This statement is true. Option B. If the machine is connected and running a TCP IP protocol stack, it should respond to the ping datagram with a datagram of its own. This statement is also true. If ping encounters an error condition, an ICMP message is not returned. This statement is false. An ICMP message is returned when ping encounters an error condition. Ping displays the time of the return response in milliseconds or one of the several error message. This is also true. So we are asked to find out the false statement. Option C is the false statement and it is the right choice here. This is a question from computer networks. A router uses the following routing table. A packet bearing the destination address arrives at the router on which interface it will be forwarded. So the basic task to do here is that we perform AND operation between the given IP address with the subnet mask and which results in the destination that is same as given here, it will be forwarded. But there can be multiple matches. So then we forward it to that interface which has the longest mask. So ideally the first method will be to perform the AND operation with the longest mask and then go on. So the longest mask here is this. So let's perform the AND operation. It will be 144.16.68.117 with 255.255.255.224. So performing AND operation with these 3 octet would result in the same value, that is 144.16.68, as these will be all ones here. Now we need to perform the AND operation between 117 and 224. Let's write the binary value of 117 and 224. So the binary value of 117 would be 0, 1, 1, 1, 0, 1, 0, 1, and 224 would be 1, 1, 1, 0, 0, 0, 0, 0. Performing the AND operation, we get 0, 0, 0, 0, 0, 1, 1, 0. This would result in the value that is 68.96. This value is 96. This is not the destination IP. So this is not matching. Now next, let's go with the next matching longest IP mask. Longest mask. So here we have 225. Let's write the IP once again. IP is 144.16.68.117 and the mask here is 255.255.255.0. So since all the first three octets are same, there is no need to perform the AND operation in this. Now 117 is written as 0111 0101. So 0 in binary will be 0000000000. Performing the AND operation, essentially we get 0. So the final IP address would be 144.16.68.0. This is matching with the destination. Since this would be the largest mask that is matching, we forward it through interface eth2. So based on the options, option C, eth2 is the right answer. This is a question from computer networks. Which layers of the OSI reference model are host to host layers? And 4 options are given. OSI stands for Open System Interconnection. So let's write down the different layers that are present in this model. In the bottom we have physical. Then on top of it we have data link. Then we have network. On top of network we have transport. On top of transport we have session. On top of session we have presentation. On top of presentation we have application. These are the various layers in the OSI reference model. And the first 3 layers, that is these layers, are media layers. And the next 4 layers are called as host layers. So based on the options, we have transport, session, presentation, application in option A. So option A is the right answer here. This is a question from software engineering. Alpha and beta testing are forms of acceptance testing, integration testing, system testing, and unit testing. So what is acceptance testing? Acceptance testing, as the name suggests, is a testing that checks whether the system satisfies the acceptance criteria or not, and it enables the users, customers, or other authorized entities to determine whether to accept the system or not. Second one is integration testing. Integration testing is a second phase of software testing where individual units or the components are tested combinedly as a group. The third option is given as systems testing. After the unit and the components are integrated and tested, then system testing comes into play. And the fourth one is unit testing. Unit testing is the first phase of software testing where individual units or components are tested. And alpha and beta testing comes under acceptance testing. So the correct option here is option A, acceptance testing. This is a question from digital logic design. The decimal number has 64 digits. The number of bits needed for its equivalent binary representation is what? Let's find out the solution. Consider an example of 3-digit number. The maximum number that can be represented is 999, which is equal to 10 to the power of 3 minus 1. These 3 represent the number of digits involved. So similarly, the maximum number that can be represented by 64 digit is equal to 10 to the power 64 minus 1. And we are asked to find out the number of bits needed for the equivalent binary representation. So using x bits, the maximum number that can be represented is 2 to the power x minus 1. 2 to the power x minus 1. Suppose we need x bits, then we can equate it as follows. 10 to the power 64 minus 1 is equal to 2 to the power x minus 1. Taking log on both sides, we get log 10 to the power 64 to the base 2 is equal to x, because log 2 is 1 and log of 1 is 0. So solving again, we get 64 into log 2 to the base 10 is equal to x. So log 2 to the base 10 is approximately 3.3. So solving this, we'll get x is equal to 64 into 3.3, which is equal to almost equal to 211.2. So the closest answer is 213. So option B is the correct answer here. This is a question from computer organization. In x equal to m plus n into O divided by p into q, how many one address instructions are required to evaluate it? So in one address instruction, an accumulator register is used to perform all the instructions. So we use accumulator register. That is the first point. Load and store operations are performed to fetch the values of operand from registers or memory to the accumulator and to store the value of accumulator to a memory location. So the instruction that is required to perform the following code is, since it is given as x equal to m plus n into O divided by p into q, we write it as follows. So the first operation would be to, following the rule of BODMAS, let's consider this bracket operation first. Now first operation is load n, that is, let's denote accumulator as AC. This accumulator will be loaded with the memory location of n. Now we multiply it with O, that is, in the accumulator what happens is the accumulator value will be multiplied with the memory location of O. Now we add it with M, that is, add M. So inside the accumulator the current value will be this multiplication result. This is n into O. This would be there in accumulator. This will be added with memory location of M. Now we need to save this value. So we are store the result as T. So to the memory location T, we are storing the value of accumulator. Now we need to again load the value P to the accumulator. That is, to the accumulator, memory location P is loaded. Now we are multiplying it with Q. So to the accumulator, the current accumulator value is multiplied with memory location of Q. The next step would be dividing the whole result with T. So that is, with accumulator, we are dividing AC by M of T. And finally, we are storing the result. Store the result to memory location X. That is, memory location of X will contain the current accumulator value, which is the result of this expression. So let's count the number of instructions. 1, 2, 3, 4, 5, 6, 7, 8. So the correct answer is option C, 8. This is a question from computer organization. The minimum time delay between initiation of two independent memory operations is called what? And four options are given. Option A, access time. Access time is the time that elapses between initiation of an operation and completion of an operation. So it is not the time delay between initiation of two independent memory operations. So access time cannot be the right answer. Now let's see cycle time. Cycle time is the time measured between the start to access one memory operation from RAM and the next access that can be started. It is the minimum time delay between initiation of two independent memory operations. So cycle time is the right answer here. Then we have option C, rotational time. Actually, rotational time is the time taken to read or write a head from one sector to another. So that is rotational time. Latency time is actually the delay that can occur in a network when an action is performed. So based on the options, option B, cycle time, is the correct answer here. This is a question from digital image processing. Which of the following compression algorithm is used to generate a PNG file? LZ78, Deflate, LZW, and Huffman. So PNG uses a non-patented lossless data compression method known as Deflate. So based on the options, option B is the right answer here. This is a question from operating system. Dirty bit for a page table is used for 4 options are given. Helps avoid unnecessary writes on a paging device. Helps maintain LRE information. Allow only read of a page. None of the above. Dirty bit is used to keep track whether a page in cache has been modified or not. That is the important point. Dirty bit, it keeps track of page in cache being modified. Dirty bit is set when page is needed to be modified and it needs to be copied back to the main memory. So it is used to avoid unnecessary writes on a paging device. So based on the options, option A would be the right choice here. This is a question from image processing. Which of the following is not an image type used in MPEG? And 4 options are given. A group of pictures can have the following picture types. First one is iframe. That is intra-coded picture. It is a picture or a frame that is coded independently of all other pictures. The second one is p-frame or predictive coded picture. It contains motion compensated difference information relative to previously decoded picture. Each p picture can have only one reference picture, and that reference picture must precede the p picture in the order of display. The next one is b frame or b picture. It is bi-predictive coded picture. It contains motion compensated difference information relative to the previously decoded pictures. Each B picture can have only 2 reference picture, the one which is preceding the B picture in display and the one which is following the initial B picture. Third or the fourth one is D picture or D frame. It stands for DC direct coded picture. It serves as a fast access representation of a picture for loss robustness or fast forward. So D picture are the one which is usually used in MPEG. And which of the following image type is not used is A frame, because it is actually not part. These are the 4 frames that are used in any group of pictures. So option A frame is the right answer. This is a question from multimedia. Consider an uncompressed stereo audio signal of CD quality which is sampled at 44.1 kHz and quantized using 16 bits. What is required storage space if a compression ratio of 0.5 is achieved for 10 seconds of this audio? So, given the sample frequency as 44.1 kilohertz, which is equal to 44.1 into 1000 hertz, which is equal to 44100 bits per second. This is a stereo audio signal, so it will need 2 channels. 2 channels are needed. While converting to MP3, it will need 16 bits to represent one sound signal. 16 bit for one sound signal. So bit rate is equal to 2 into 16 into 44100, which is equal to 1411200 bits per second. Now we are given the compression ratio as 0.5. Compression ratio equal to 0.5. The compressed bitrate will be half of the original bitrate. The initial bitrate is 1411200 and it will be half means divided by 2. It will be 705600 bits per second. So for 10 seconds data will be equal to 705600 bits, which is equal to 882000 bytes. Now converting it to kilobyte, that is we will get 861.33 kilobytes. So the closest answer here is 860. So based on the options, option C, 860 kilobyte is the right choice. This is a question from multimedia. What is the compression ratio in a typical MP3 audio file? Audio is recorded in a frequency of 44.1 kHz. So audio is recorded at 44.1 kHz frequency. While converting to MP3, it used 16 bits to represent one sound signal. For stereo, two channels are used. Hence, two channels of 16-bit audio at 44.1 kHz is equal to 2 into 16 into 44.100. This is converting this into hertz, which is equal to 1411200 bits per second, which is equal to 172 kilobyte per second. Now the compression ratio is at compression ratio is 128 kilobit or 16 kilobyte per second, which is equal to 172 divided by 16. When divided, we get 10.75 is to 1. This is the answer. 10.75 is to 1. So the closest option is 10 is to 1. So option D is the right choice. This is a question from C programming. We are given a following C code and we are asked to find out the conditions that will make S2 to be executed. Let's rewrite the code properly. If A greater than B, then if B greater than C, S1, else S2, and this loop is closed. So the outer if statement has scope till the end of inner if and else statement. So in order for S2 to be executed, the first criteria that should be satisfied is A should be greater than B, A greater than B. So this is eliminated. This is also eliminated. Ideally, this statement is also eliminated. Now, in order to reach S2, B greater than C should be violated. So B should be less than or equal to C. These two conditions has to be satisfied. And based on the options, option D satisfy this. That is A greater than B and B is less than or equal to C. So option D is the right answer. This is a question from C programming. If n has 3, then the statement A of plus plus n equal to n plus plus. And 4 options are given. Assigns 3 to A of 5, assigns 4 to A of 5, assigns 4 to A of 4. What is assigned is compiler dependent. Actually, this results in undefined behavior. And what happens is actually dependent on the compiler. So correct option is option D. There are two ways usually the compiler performs this. One way is first n++, then calculate ++n for index value. The second method is calculate ++n for index value and then find n++. So this is are actually compiler dependent. So correct answer is option D. This is a question from C programming. We are given a main function. Inside it, we are calling the inc function thrice. And in inc function, a static variable x is declared and we are performing pre-increment operation. So when the first inc is called for the first time, what happens is in the static area of memory, there is a variable created x. And since it is not assigned any value, the default value assigned is 0. Now we are performing plus x. It will be 1 and 1 will be printed. So the initial output would be 1. Then it will be calling 1, 2 and 3. The second increment operation. Now the x value is 1. It is performing pre-incrementing. It will be 2. So we'll print 2. Now after this, again the third increment operation is called or inc operation is called. It will be printing plus 2. That is 3. So it will print 3. So this is what that is printed 1, 2 and 3. So based on the options, option B prints 1, 2, 3 is the right answer. This is a question from C programming. We are given I is equal to 6720, j equal to 4. While I mod j equal to 0, I equal to I by j, j equal to j plus 1. On termination, what will be the final value of j? So the condition that is to be checked here is I mod j is equal to 0. Now let's write the I value here and the j value here. Initially we are having what? I mod j, that is 6720 mod 4. This is equal to 0. So this is true. Now the I value will be I equal to I by j, that is 6720 divided by 4, which is equal to 1680, and the j value is j plus 1, that it will be 4. Sorry, it will be 5 because 4 plus 1 is 5. Now we are having 1680 divided mod 5, which is also equal to 0. So this is true. Now we are dividing it with 5. 168, here it is 0, 1680 divided by 5, which is equal to 336, and j will be 6. Now 336 mod 6 is also equal to 0. So true. Now 336 divided by 6 is equal to 56, and j will be 6 plus 1, 7. Next we have 56 mod 7, which is also equal to 0. So it is true. So we have 56 divided by 7, which is equal to 8. Here we have 7 plus 1, 8. Now we have 8 mod 8, which is equal to 0. This is also true. So we have 8 by 8, which is equal to 1. J will be 9. Now we have 1. 1 mod 9 is not equal to 0. This is false. So the condition is violated and this is getting terminated. On termination, the value of j is equal to 9. So based on the options, option C is the right choice. This is a question from C programming. Consider the following declaration. We are given an integer variable a pointer variable b, and another pointer variable c. The program fragment is as follows. We are assigning a equal to 4, then star star c equal to 5. What does the following code does? So let's try to solve it. So a is an integer variable. It is stored at memory location 100, and we are assigning the value 4. Now b is a pointer variable that is storing the address of a. That is, it is pointing directly to here. This is b. The memory address of b is 200. Now c is another pointer which is storing the address of b. That is, it is pointing here, and the address is 300. Assume. Now to access the value of a through b, we use star b, and to access the value of a through c, we use star star c. Star c is essentially ampersand b because we are trying to access the content in c. So what happens here is that a is initially 4. Now star star c means star c. It means the content of c. It will be 200. 200 will be pointing here and will reach here. Then next star means it will move to 100. 100 will be reaching here. Then it will modify the value and make it 5. So finally the value of a will be equal to 5. Now based on the options, option D assigns 5 to a is the right answer. This is a question from C programming. We are asked to find out the output of this following program. We have a static array X and values are assigned. Then there is a loop which is assigning values to this, and then we are printing the value. What will be the final output? So this is a static array. So let's first draw the array. So we have the values 1, 2, 3, 4, 5, 6, 7, and 8. And the index values are 0, 1, 2, 3, 4, 5, 6, and 7. Now we are given I. I is equal to 2 initially. Now let's see what happens here. The value is x of I is equal to x of I. This is what is happening. X of 2 is equal to x of 2. Now x of 2 means what is the value at 2? Value of x of 2 is 3. So x of 3 will be having the value of x of 2. So x of 2 means 3, and this 3 will be assigned to x of 3. So 3 will be here. Now for I equal to 3, we have x of 3 is equal to x of 3. At x of 3, what is the value? Value is 3. So x of 3 will be assigned the value x of 3. So 3 will be the value here. Now I is equal to 4. X of 4 is equal to x of 4. So x of 4 will be having what value? At x of 4 we have value 5. So x of 5 will be assigned the value of x of 4. At x of 4 we have 5. At x of 5 we have 6. So at this 6 will be replaced by 5. Now I equal to 5. X of 5 is equal to x of 5. At x of 5 we are having the value 5. So x of 5 will be assigned the value of x of 5. So we are assigning the value 5 itself. Now I equal to 6. The loop breaks. Now we are printing the values from 0 to 7. So the values are this: 1, 2, 3, 3, 5, 5, 7, 8. And based on the options, option A, 1, 2, 3, 3, 5, 5, 7, 8. So option A is the right choice here. This is a question from C programming. Which of the following has the compilation error in C? Option A, int n equal to 17. There is no error in assigning an integer value, and the value here is 17, which is within the range of the integer. So this is not the right answer. There is no compilation error in this. Now char c equal to 99. No error in this also, since 99 is an ASCII value, hence The character has ASCII value 99 and it will be assigned to char C. This is also not the right answer. Float f is equal to float of 99.32. No error is in this also because float data type allows float typecasting. This is also having no issues. Ideally, hash include stdio.h. This also doesn't have a issue in the ideal case. But there can be an issue which can occur when moving the header file to another location. Suppose if you have installed the Turbo C or some other C compiler in one location and we are moving the header file to some other disk drive, then when we try to include hash include stdio.h, then if we have not mentioned the new location to the compiler, then it will be finding difficult or causing a compilation error because the drive location is not found. So in that case, this can result in a compilation error. So based on the options, option D is the ideal choice. This is a question from C programming. The for loop for I equal to 0, I less than 10, plus plus I. Printf percentage %d, I and 1. This is AND operation. That is bitwise AND. And what is the question is we are asked to find out what will be the printed value. So ideally, we have to perform bitwise AND operation with values I equal to 0 till I equal to 9. Now, how many bits are required to represent 9? So we require 4 bits. So, and we are performing AND operation with 1. So for 0, we will be performing 0, 0, 0, 0 and with 0, 0, 0, 1. This would return the value 0. So initially it will print 0. Then for 1, we will performing 0, 0, 0, 1 and the bitwise operation with 1. We will get 1 as the answer here. So this will print 1. With 2, we are printing 0, 0, 1, 0, 0, 0, 0, 1. This would result in 0. Now with 3, we are printing 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0. This would print 1. So ideally what is happen is the LSB bit, if it is 1 for the number, then we'll get result 1. If it is 0, then we will get 0 as the answer. So what happens here is let's write the numbers from 0 to 9 here. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. So the values are 0, 1, 2, 3, 4, 5, 6, 7 and 8. It will be 1, 0, 0, 0. This will be 8 and 9 will be 1, 0, 0, 1. This will be 9. So we just need to check if what is the values of the MSB here. And if it is 0 and 0, 0 and 1, it will be printing the value 1, value 0. And if it is 1 and 1, it will be printing the value 1. So based on this, what will happen is we'll get 0 here, we'll get 1 here, 0 here, 1 here. This will be alternating. It will be alternating like 0, 1, 0, 1, 0, 1 and it will alternate like this. So based on the options, option A will be the right choice because it is alternating like 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So option A is the right choice. This is a question from C programming. Consider the following statement. Hash define hypotenuse A comma B is SQRT of A star A plus B star B. The macro call hypotenuse A plus 2 comma B plus 2 and what will be the result. So the macro is defined with hypotenuse of A comma B means square root of A star A plus B star B. Now we are calling hypotenuse of A plus 2 comma B plus 3. So this will result in square root of A star. This will be A and this will be B. So A plus 2 star A plus 2 plus B plus 3 star B plus 3. This is what that is returned. Now square root of what happens here is like based on Bodmer's rule, we'll be multiplying this 2a and this 3b first. So a plus 2a plus 2 plus b plus 3b plus 3. This will result in square root of 3a plus 2 plus 4b plus 3. We can again solve it like square root of 3a plus 4b plus 5. So based on the options, option D, find the square root of 3a plus 4b plus 5 is the right choice. This is a question from software engineering. If in a software project, the number of user input, user output, enquiries, files, and external interfaces are 15, 50, 24, 12, 8 respectively, with complexity average weighing factor, the productivity if effort is 70% month, and 4 options are given. Let's write the functional units and their weighing factors based on average, low, and high. So the functional units are here and the weighing factors based on low, average, and high. These three are weighting factors or weighing factors. Now, for external input that is EI, it is 3, 4, and 6. For external output EO, it is 4, 5, and 7. For external inquiries, it is 3, 4, and 6. For external logical files, it is 7, 10, and 15. And for external interface file, it is 5, 7, 10. This is EI, this is EO, this is EQ, this is ILF, and this is EIF. This is how it is denoted. Now, the formula for average weighing factor is equal to, since we are finding it for average, we are doing it like EI into 4 plus EO into 5 plus EQ into 4 plus ILF into 10 plus EIF into 7. So this will be 15 into 4 plus 50 into 5 plus 24 into 4 plus 12 into 10 plus 8 into 7. Solving this, we will get 582. Now, if effort is 70% per month, then the productivity will be 0.7 into 582, which is equal to 407.4. And the closest answer here is 408.74. So based on the options, we can choose option B as the right answer. This is a question from operating system. Suppose two jobs, each of which needs 10 minutes of CPU time, start simultaneously. Assume 50% IO wait time. How long it will take for both to complete if they run sequentially? So 50% IO wait time means that 50% of time CPU waits for IO. So let time in total is equal to 2x. Then x time CPU is doing IO and x time it is running the process. So time taken to run a process is time to run process is 10 plus 10, which is equal to 20 minutes. And therefore total time will be 2 times the time to run the process, which will be equal to 40 minutes. So based on the options, option D, 40 will be the right choice. This is a question from databases. If D1, D2 till Dn are domains in a relational model, then the relation is a table, which is a subset of, and 4 options are given. So given set of domains D1, D2, etc. Dn, the Cartesian product D1 cross D2 cross etc. Dn is set of all n tuples that are ordered, set of all n tuples that are ordered in this manner D1, D2, etc. Dn, such that D1 belongs to D1, D2 belongs to D2, etc. Dn belongs to Dn. So the mathematical relation on D1, D2, Dn is a subset of the Cartesian product D1 cross D2 cross etc. Dn. So based on the options, option B, D1 cross D2 cross etc. Dn is the right choice. This is a question from microprocessor. The contents of the flag register after execution of the following program by 8085 microprocessor will be what? We're performing sub A, that is subtracting from accumulator, move immediate B and the value 01 in hexadecimal, decrement B and halt. So first of all, what is flag register? Flag register. It is an 8-bit register that shows the status of the microprocessor before or after an operation. Out of these 8 bits, only 5 bits are defined. The rest 3 bits are don't care. And the bits are defined as follows. We have D7, D6, D5, D4, D3, D2, D1 and D0. The bits defined are Z, S, Z, don't care, AC, don't care, P, don't care and CY. So S stands for sign flag, Z for zero flag. Then AC stands for auxiliary carry flag. Then P stands for parity flag. And CY stands for carry flag. And XR don't care. So all the instructions in the arithmetic group affect the 0, sign, parity, carry and auxiliary carry flags according to the standard rules. Data transfer instruction set such as move immediate does not affect the flag registers. Decrement instruction can affect all the condition flags except carry flag. These are the basic rules. Now let's perform the analysis. The first instruction that we are performing is subtracting the value from accumulator, which implies A minus A, which results in 00 in hexadecimal form. So this would result in the modification of the flags as follows. The flags are S, Z, X, AC, X, P, X, and CY. So the sign would be positive. So 0. Z, it's 0. So 0 flag is set. Then this is don't care. So we are assuming it as 0. Then auxiliary carry flag is not set. This is don't care. The parity flag is set. This is don't care. And the carry flag is also not set. This is the basic condition after first operation. Now let's see what happens in the second operation. The second instruction is move immediate B, 01 H. So what happens is to B we are moving 01 in hexadecimal. Move instruction, it does not affect the flags. The next instruction is decrement B, DCR B. So what happens here is B minus 1, which is equal to 00 in hexadecimal form. So how to perform this decrement? We perform addition of 2's complement to perform the decrement operation. So 01 H plus 2's complement of 01 H to perform the decrement operation. 2's complement of 01 H is equal to 1111 in hexadecimal form. So 00000001 plus 1111. The result would be 1 plus 1 10. 1 plus 1 10 means 0 and 1 gets carried over here. Same thing repeats. 0 0 0 0 0 0 1 and a carry gets generated. Carry generated. So as a result, AC flag is set to 1. Carry flag will be unaffected in case of decrement operation. So the final status of the flags will be as follows. S will be 0. Z in the initial stage it was 1, so it is not modified. Don't care, we are assuming it to be 0. Auxiliary carry flag is set to 1. Don't care is set to 0. Parity flag is set to 1. Don't care is set to 0. And CY flag is set to 0. So the contents of the flag register would be 54 in hexadecimal notation. So the final answer is option A, 54H. Actually, the don't care can be either 0 or 1. So here we are assuming that it is 0. If we have assumed it as 1, then the answer would have been different. So actually this is not a right question because the don't care can be either 0 or 1. So proper information regarding what would be the don't care value has to be provided by the examiner. So assuming the don't care value is 0, we got the answer as option A, 54H. This is a question from database. The maximum length of an attribute of type text is what? And 4 options are given. 127, 255, 256, it is variable. So the maximum length of an attribute of type text is variable. Therefore, the correct answer here is option D, it is variable. For text storage requirement, it depends upon the following factors. One is actual length of the column value. and second one columns maximum possible length. It depends upon these two values, so it is variable. Option D is the right answer.